Welcome to Microsoft Mechanics. Coming up on the show, we take a look at the latest updates to Microsoft's remote desktop services, from advances in graphics performance that improve the experience of GPU-intensive apps, to how to overcome the 9 AM log-on storm with new enhancements to the connection broker for up to 10,000 concurrent log-ons. And keep watching as we show you how to optimize your deployment for the cloud with Azure. So I'm joined today by Scott Manchester from the Remote Desktop Services engineering team here at Microsoft. Scott, welcome to the studio.
Thanks for having me on the show.
So Microsoft's had a lot going on in the Remote Desktop Services for a while. What's new?
So Remote Desktop Services enables users to access Windows virtualized desktops and applications from anywhere on any device. We make client applications for Windows, Windows Phone, Android, iOS, and Mac. If you're an IT admin, you've probably deployed RDS on-prem in your own data centers on your own hardware. What I'm going to show you today is how we can now take those deployments to the cloud and benefit from the elasticity, scalability, and better cost modeling of using cloud deployments.
So for those people who may not have looked at Remote Desktop Services for a while, what have we actually got in the Windows Server 2016 release, which is really new?
So there's really three areas of improvements that we had for 2016. The first is around our graphics performance. The second is around scalability. And third, as I mentioned, is optimizations for the cloud.
So let's talk about graphics performance. What's new there?
One of the major enhancements we made with Server 2016 was the inclusion of a new technology called Discrete Device Assignment, or DDA. With DDA, we can physically map a GPU to a VM and run the native graphics drivers. So we have full app compatibility and all the performance of the GPU in the virtual machine. So not only do you get the benefit with traditional applications like Office, we can also run more GPU-intensive applications now, like Adobe Illustrator, Portrayal, or SolidWorks. Let me show you an example. So here in this VM, I've got DDA running, and you can see when I bring up Device Manager, there's actually a physical GPU available in this VM. In this case, it's an NVIDIA Tesla M60. This is one of two GPUs that's available on the physical card that's in this chassis. And this chassis actually has two of these cards. So there's a total of 4 GPUs in the physical hardware, and I've used Hypervisor to map one of those GPUs to this VM. So now I'm running the native driver here in this VM and get near bare metal performance. Now I want to point out also that DDA is an open standard. So we've worked closely with NVIDIA, but this is open to other device manufacturers as well. So the first thing I want to show you is this eDocs Viewer app from Dassault. And here I've loaded up a 3D image of a jet engine. So I'm actually going to start this rendering. So I'm going to rotate this engine around, and you can see as it's drawing, it's very smooth. And you can see, very high detail that we get with this. But I'm cheating a little bit. So let's really tax this system here, and let's turn on some of the effects.
Wow.
So here you can see I've applied, this high surface visualization here with reflections, and you can see it's still rendering very smooth. And you can even make out some of the background images in the reflections here. And I'm getting a really smooth experience here.
That's pretty incredible. What would this have looked like in a virtual machine that wasn't running DDA?
That's a great question. So this application, like many CAD/CAM applications, have a dependency on OpenGL. So let's do this. Let's shut that down. And let me switch over to a virtual machine that doesn't have GPU. So here in this machine, I'm going to bring up Device Manager, and I'm going to show you that here there's no VM, right? And let's load up that same image here, right? So let's start the transition. You can see even without the effects, this thing runs really choppy. The frame rate is really poor. This would be almost impossible for me to actually do any development, any kind of design work on this. And if I turn on the visualizations here, you can see that they're not even able to reproduce the reflection properties on the surface of this object. So this would not work well for someone trying to do this high-end CAD/CAM work as a designer.
Yeah, that is a truly different experience. What other things have we actually done inside of the improvements?
Yeah, let me switch back over to the GPU-powered VM, and let me show you another example here. So here I'm going to run a web page that uses WebGL, and you can see here the performance we get as it's doing all this animations here. So very smooth, high frame rate. So this works great.
That's pretty incredible. I mean, to get that level of fidelity inside of a VM is pretty amazing. How much further can you go?
I'm going to show you another hypothetical example here, right? So this may not be your traditional enterprise type of deployment here, but I've got this really cool game engine sample by Unigen here. So let me run this and show you just the kind of performance that we can see with DDA. So here I am in this 3D world within this game engine here. And I'm going to pause this here for just a second and show you just the level of detail we can see in this 3D world. Now again, this is all being rendered real time, and you can see we've got a number of different surfaces and very complex shapes that are all being created real time. So you can see the level of detail in the grass and the various textures on the various objects here. And just to prove to you this is in real time, I'm going to take control of this game, and bear with me again. I'm not much of a gamer. My kids call me a noob, but I'm gonna fly up here, and then we're gonna look back down at our world, and you can see it's a pretty complex world with lots of different shapes, lots of different textures. I'm going to turn on the wireframe here. You can actually see the amount of polygons we're using to generate this world. And you can see we're really taxing this GPU. But if you look in the upper right-hand corner, you can see we're still running at like 80 frames per second, even generating all this complex imagery here. So I'm going to zoom back down a little bit. And you can see as I get closer to these surfaces, the number of polygons that this thing is drawing, it's just incredible. And if I turn down the intensity of the polygons here, you can see the frame rate jumps up well over 100. And when I turn on all the additional textures and tessellation, it drops to around 50. One of the things I really want to point out here as we're looking at this image, not only am I getting this really high performance, but I'm getting a real crisp image that's being remoted back to me. What we're using under the covers here is our new RDP 10.2 protocol. So I'm actually encoding the images on the host or the VM using AVC 444. Now with 444, I can get near pixel perfect representation back at the client running our remote desktop client application. And better yet is I'm using hardware offload on the host, so I'm not taxing the CPU to do the encode, and I'm using hardware offload on the client. So we get great performance and very little power consumption as well. In fact, I've got one more reveal for you, Simon. We're actually running all of this demo that I've been showing you today on a new Azure NSKU.
So we have this kind of specialized hardware inside of our Azure data centers?
Yes, so this is in preview now, but coming around the end of the year, you'll be able to run production level workloads in the new Azure NSKUs.
That is absolutely incredible. It seems great that we've got all this highly specialized hardware for this. And I think that some folks are actually going to be wanting to get more density into their environments as well. Have we done anything around that?
Yeah, we've had a technology called RemoteFX since 2008 R2. And RemoteFX is a great technology for more high-density workloads, like the line of business apps we mentioned earlier. And we've given RemoteFX some love in 2016 as well. So we've added a number of performance improvements. We've added support for OpenGL 4.4 and OpenCL 1.1. And now you can assign up to 1 GB of VRAM per VDI session.
So that covers us for graphics performance. What about scalability?
Yeah, that was another major investment area for us with 2016. Our primary investment was around our connection broker. The connection broker is really the engine of an RDS deployment. It's responsible for maintaining state of all the users and which sessions and VDI instances they're connected to. So what we see in some deployments are what we call login storms, where you get this 9 a.m. Monday morning scenario where everybody's trying to connect at the same time. And that really taxes our connection broker and can cause delays in people being able to connect. So what we've done is really focused in investments on our connection broker, and we've built out this simulation tool that can really test the scalability of it and push it to its limits. So I'd like to show you a demo of this test tool and see how well it's performing now.
Yeah, let's take a look.
So here on my screen, you can see we're just getting ready to launch this test case. And in this particular test case, we've set up 1,000 users and 100 session host servers. Now we're going to have those first 100 users connect instantaneously, so it's simulating all of them trying to connect at the same time. And then we're going to have 4 users connecting every second after that. Now, just to make this even a little more complex, after 2 minutes, we're going to start to see users disconnect. So about midway through this, we're going to have users connecting and disconnecting at the same time, and our connection broker is going to be responsible for maintaining state of all those connections. Okay? So let's go ahead and start the simulation here. So here we're actually a couple minutes into the simulation, and what I want to show you is we've made, at this point in time, let's see, about 520 connections. So you can see 520 connections and 0 failures. So we're about midway through at this point in time, and we've had no failures at all. So now we're starting to see a large number of the initial users start to log off, and the remaining 500 users starting to connect. So let's jump to the end and see how well this thing performed. So here at the end, you can see our summary that we had 1,000 connections with 0 failures. Now, this was not the kind of results we used to see in previous releases of our connection broker, and really enables users to deploy much larger systems.
And that's well beyond the majority of real-world use cases anyway.
Yeah, and we've tested this to some extreme boundaries. Like we've run test cases with up to 10,000 users trying to connect and a variety of different number of session host servers as well.
You mentioned that cloud optimizations were a big part of the investments for Windows Server 2016 RDS. What have we done to bring Windows Server 2016 RDS into, say, the cloud with Azure?
Yeah, absolutely. Let me show you. One of the major investments we made was to make it really easy for you to deploy RDS into Azure. So what I want to show you is some of the QuickStart templates that we've created. So here I'm at azure.com. I'm going to go to Resources and go down to Templates. And here you can see we have almost 400 templates available to you to help you with your deployments in Azure. And I'm going to do a quick search. I'm going to type RDS. And here you can see that it's returned 4 different results for me. So I'm going to take a look at this one here in particular, the RD session collection deployment. So let me click on this. And what it shows me here is there's a few parameters that it's going to want me to fill out to be able to do this deployment. And actually, here's a button right here where I can start the deployment directly into my Azure subscription. So let me jump in. So here I'm in the Azure portal. So let me fill in those questions that it asked me to enter. So now it's going to allow me to choose which version of Windows I want to run. So I'm going to accept the default here, which is Windows Server Technical Preview, and the number of instances of the session host server and the size of the deployment. So I'm going to save these settings. And just so you can watch what's happening here, I'm going to pin this to the dashboard. And let me accept the legal terms. And let's create this. So now what you can see, this deployment is already started here. Now this will take a few minutes to run. So what I did is I did another version of this earlier today. I want to show you what would be set up for me. Here you can see all the resources that were created by this QuickStart template. So at the bottom of the list here, you can see that it created a VNet, created a public IP address, which is the front-facing IP address for my deployment. Here's a handful of virtual NICs that were created, and then a load balancer for my front end. And then there's the 2 session host servers we configured in the front. And then there's a handful of infrastructure VMs that were created as well. And what I want to show you here at the top is that it's already created these availability sets for me as well. So of course, with the session host availability set, I've got those 2 session host servers, and I can add more as I want if I want to grow this deployment. But also it created an availability set for my VMs that are supporting the infrastructure roles. So now if I wanted to go back and make this RDS deployment highly available, I could go back to those QuickStart templates, and there's another one there that'll add the additional infrastructure VMs, and now my entire deployment is highly available within Azure.
Wow, that's pretty incredible. So graphics, scale, and cloud in the Windows Server 2016 update for RDS. It's pretty amazing.
Yeah, RDS is a great solution for customers. But in addition to that, it's also a great platform for partners. In fact, just recently we made an announcement that we've partnered with Citrix to build out the next generation Azure remote app on Azure using our RDS platform. And we've also announced recently VDI using Windows 10 client in Azure, and Citrix is building a management solution for that as well.
That's pretty cool. Where can folks find out more?
Well, first thing I would encourage folks to try out the Windows Server 2016 preview that's available for download. Also, you can try out these Azure QuickStart templates today and do an RDS deployment in Azure of your own. And if you want to learn more about the Azure NSKUs, you can click on the link below.
Great stuff, Scott. Thank you very much for joining us, and thank you for watching. That's about all we have time for, but remember to keep watching Microsoft Mechanics for the very latest in updates. We'll see you next time.